All right, last lesson of Unit 5. So 5 point, well, this should say actually 5.10, which is the modeling and applications of log functions. So a log function is a really great way of taking numbers that aren't nice to look at, so either really large or really small, and putting them into easier to comprehend numbers. That's what this whole part right here is saying. There's a log scale, okay? So in our first set of application problems, one way of representing that log scale is the pH scale. And what I mean by this whole taking large numbers or small numbers, things that aren't nice to look at, if we look on the bottom here, we're taking concentrations that are really small, like 10 to the negative 7. So that's like me saying 0.0000, what's that, 1, 2, 3, 4, 5, 6, 1, 7, right? Like that is not a nice number to look at, right? Like imagine comparing that directly to what's on the other side of the scale, 14. So that's 13 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So imagine just comparing these two numbers. Like that is really difficult to look at. Like you have to sit there and count the zeros to figure out how much more basic something is. It is much easier for me to say, hey, I'm going to compare 7 to 14, right? Like it's very clear that, oh, okay, yeah, 14 is a bigger number, right? So that is the application of log functions. It takes numbers that are not nice to look at and put them into something that's more digestible, something that we can look at and be like, yeah, that one is either smaller or larger, okay? All right. So let's just get into the problems. So in these first set of problems here, we are going to be just applying the pH formula, which is negative log multiplying the concentration of hydrogen ions. So those who take chemistry have probably experienced this or seen this before. So your variable H plus is the concentration of hydronium ions. Do you need to know chemistry to succeed in this lesson? No. Okay, everything's going to be defined. Okay, it's just like any other math problem where I defined, like in the previous lesson we defined temperature of the oven and time of the oven. Just read the problem and just figure out what variable is it giving me. So tomato juice has a hydronium ion concentration of approximately 0.001. So this is the variable H plus. What is the pH? So the question is saying find pH, right? There is only two unknowns. There, that one or H plus. So we're going to apply our pH formula, which is pH is the negative log of H plus. And I should note, do you have to memorize any of these formulas for these application of logs? No. If I'm asking you an application log question, I'm going to give you the formula that you need, okay? Because I'm not testing you on your chemistry knowledge in math. So now just plug in the known, so solve for pH. So pH, the power of hydrogen would be negative log, the concentration of hydrogen, so that would be 0.0001. And if you just take your calculator and you type log 0.001, you will find that that is going to give you an answer of 4. Actually, log 0.0001, yeah, 4. Just want to double check. My mental math, not the greatest today. So you should have got an answer of 4. B. Blood has a hydronium ion concentration of approximately 4 times 10 to the negative 7 moles per liter. Is the blood acidic or alkaline? Meaning that, are you on the left side of your acidity? So this side right here, like, is your answer going to be, is pH going to be bigger than 7? Sorry, those bigger than look just like 7s. Or is it going to be, that's actually less than 7, or is it going to be bigger than 7? So let's calculate it. our pH is negative log, and the concentration it's giving me is 4 times 10 to the minus 7. All right, so you on your calculator, by the way, if you don't know how to type this in, you have a button that looks like this. It has like double E's, or you might see it as EXP. That's your ability to put scientific notation. If you don't have either one of those buttons, all this is telling you is, hey, take 4 and divide it by 10 with 7 zeros, okay? So you're essentially shifting this number down 7 places. So I'll write it like that. That'd be 1, 2, 3, 4, 5, 6, 7, okay? And if we evaluate that, that is going to give us a pH of 6.4. So because it is a number that is less than 7, that means you are acidic. So this would be acidic. And again, do you need to know this scale? No. If I'm asking you a pH question, I'm going to give you this, and I'm also going to give you this formula, okay? Orange juice has a pH of approximately 3. What is the concentration of hydronium ions in the juice? So now you're calculating for H+. This problem is saying isolate the problem for H+. So if I'm giving you your pH, and let's just rewrite the formula, H+, I'm giving you the pH, so the pH is 3 in this problem. So that's 3 being equal to negative log H+. So now just isolate for H+. So we first take this negative across. So that's negative 3 log H+. And then we have a 10 here. So that means we write it as 10 to the minus 3 is H+. And that would be fine. You can leave your answer like that, 10 to the negative 3, or you can write it as a decimal, 0.001. Either answer would have been fine, okay? Which has a greater concentration of hydronium ions? Orange juice or tomato juice, and by how much? Well, let's just look at what did we calculate when we did orange juice. So orange juice was our answer from C. We had 0.001. And when did we do tomato juice? Tomato juice was our answer from A, or actually it was the given concentration from A. So tomato juice, it gave it to us as 0.0001. 3 zeros. 0.1. So which has a greater concentration of hydronium ions? Well, this one. That's just the larger number. And how many times larger is it? Well, how many times larger? So that means just set up a ratio. So how many times larger? So really my ratio is I'm just setting up orange juice divided by tomato juice. So this would be 10. So orange juice is 10 times stronger. So the second set of application that you're going to be encountering when it comes to logarithmic function is the Richter scale. And the Richter scale, I'm sure we've all heard it before, is a way of measuring earthquake magnitudes. And every time you move up 1 on the Richter scale, essentially it is saying you're moving 10 times stronger, okay? So going up 1 on the scale is a moving up essentially by like a whole factor of 10. So for example, an earthquake of magnitude 6 is 10 times stronger than an earthquake of magnitude 5. So if I have an earthquake that has a magnitude of 7, well, how much stronger would it be than if I had an earthquake of magnitude 5? Well, I am moving 2 spaces on the scale. So essentially, I am saying, okay, well, you are 10 times 10, because every time you go up 1, you are increasing it by a factor of 10. So a magnitude 7 earthquake is 100 times stronger than that of magnitude 5 earthquake. Okay, so just as we did in the pH, you have a formula to calculate magnitude of earthquakes, and then we also have a second formula that allows us to calculate the comparison between earthquakes. Okay, so you will be given both these formulas. All right, so just knowing what piece of information a question is giving you and where to put it. Okay, so the variables are defined for you, where in the first equation that's given, m is the magnitude. So if the question gives you a magnitude, that is the variable m. And then you have this fraction on the inside here, and that is just comparing the intensity of earthquakes. All right, so it's saying like how many times greater is this earthquake than another earthquake. In this case, you're only talking about one earthquake, and so there needs to be a reference point, and that's what this I naught is right here. So some earthquake of magnitude 7, right, it will have its own intensity, and the way we get a magnitude of 7 here is we compare the intensity of the earthquake to some standard, some relative. There needs to be something we have to make it relative to. Don't worry so much about that, okay? I'm mostly going to be asking you questions like this. And this one is comparing two different magnitudes. So it's just a modified version of this equation right here. And you notice the main difference is that this reference point right here is eliminated in the second equation. And in the second equation, what we are doing is we're comparing the intensity of one earthquake to the intensity of another earthquake. And that log of that intensity ratio is really just equal to their magnitudes subtracted from each other. So that's a lot of talking. Let's just see an example and it will make a lot more sense, okay? So A, in 2010, Haiti experienced an earthquake of magnitude 7. In 2011, the earthquake off the coast of Japan was 100 times stronger than the one in Haiti. What was the magnitude of the large earthquake in Japan? Okay, so what it's saying is that you have some intensity Japan, and you had some intensity of an earthquake in Haiti. So let's call that H. Well, when we did the division of these ratios, it is telling us that it is 100 times stronger. So taking the intensity of Japan and dividing it by Haiti, well, that's going to be equal to 100. So I'm going to have on the inside of my formula here, I'm going to have log intensity of J over intensity of Haiti, Japan. And that's going to be equal to, well, whatever is up here, right? So that's IJ. So notice how the formula is I2. I write its magnitude first. So this would be me saying the magnitude of Japan minus the magnitude of Haiti. So the question says, what was the magnitude of the large earthquake in Japan? So I am solving for, in this case, the magnitude of Japan. It gave us the magnitude of Haiti right here. It told us that the magnitude of Haiti was 7. And then I showed you we already got this piece of information here too. That's 100. So we have the magnitude of some earthquake that happened in Japan subtracted by 7 is equal to log, and then IJ over IH, that is 100. So then the earthquake that happened in Japan was log 100. So 10 to the what gives you 100? Well, that's 2. Plus 7, so I'm bringing this 7 across here. So all I did was I evaluated this log and wrote it as 2, and I brought the 7 over. So the magnitude of my earthquake in Japan was a scale, was 9 on the Richter scale. Okay. C. The strongest earthquake in recorded history took place in Chile in 1960, causing a tsunami that affected countries on the opposite side of the Pacific Ocean. The earthquake had a magnitude of 9.5. The strongest earthquake that has occurred in Burlington, Ontario occurred in 1983. I'm just gonna get some water. All right. The strongest earthquake that occurred in Burlington, Ontario occurred in 1983 and had a magnitude of 3.1. How many times stronger was the earthquake in Chile than the one in Burlington? So how many times stronger? What that is saying is, hey, compare your ratios. So you're comparing the ratio I2 over I1. Well, which one is it asking me to compare to? So how many stronger was the earthquake in Chile than the one in Burlington? So essentially it's saying compare the intensity in Chile to the one in Burlington. Let's call it IB. So if I set up my formula, I have log I2, so I2 in this case would be the intensity of Chile, over the intensity in Burlington. Well, that means I need to know the magnitude of Chile minus the magnitude of Burlington. And so we're going to be solving for this. The problem is saying solve for this ratio right here. It gave us what MC and MB were. So the magnitude in Chile, this was MC, being 9.5. And the magnitude in Burlington was right here, 3.1. So we have 9.5 subtracting 3.1, and that is equal to log our ratio of intensities. So 9.5 take away 3.1, well, that is going to be 6.4 log IC over IB. So the ratio of intensities IC over IB is just 10 to the 6.4. And if we calculate what that is equal to, that is 10 to the 6.4, 886.4 times greater. So quite significant. And I mean, that goes back to, the benefit of logarithms. It's like saying, hey, you have an earthquake of 2,511,886.4. It's a mouthful, and it's really hard for people to comprehend how much greater of an earthquake it is. But I can much more easily digestible take in, 9.5 versus 3.1. Okay, yeah, this is a bigger number. But it just happens to be a significantly, like going up that much on the Richter scale is huge. And then the third type of application of logarithmics is the decibel scale, so sound essentially. And it's really like almost near identical to what we just did with the Richter scale. Okay, so if you think about this being M2 minus M1, right, and you have the same ratio of intensities. Well, in this case, these variables B or beta, those are going to be the difference in sound levels. So instead of it being like a magnitude of an earthquake, it's your sound levels. So this is where you're going to get your betas from. And then I2 over I1 is the ratio of their sound intensities. So let's apply the formula. How many times as intense as a whisper is the sound of normal conversations? So in this case, what I'm asking you to compare is how many times is intense. So again, I'm asking for the ratio of I2 over I1. In this case, it's saying a whisper relative to a conversation. So I need to know what is the intensity of my whisper relative to the intensity of my conversation. Let's call it IC. So let's apply the formula. The formula says B2 take away B1 is equal to 10 log your intensities of I2, I1. Well, in this case, my I2 is my whisper, so I'm asking you, that's the whisper, and this is conversation, sorry, not one. Oh yeah, conversation. Okay, so that means we need to know what is the sound level of the whisper and conversation. So if I get the whisper is right here, so that would be 30, and the conversation is going to be 60. How many times as intense as a whisper is the sound? Yep, sorry, just want to make sure I set my ratio up properly, because I'm going to get a negative number here. Okay, so negative 30 on the left-hand side there is equal to 10 log IW over IC. So if I rearrange and solve for IW over IC, I need to first divide both sides by 10. So I'm going to divide this by 10. And these cancel. I'm going to run out of room, so let me start working here. I'm going to have on the left-hand side negative 30 over 10, so it's going to be minus 3, is log IW over IC. So isolate for IW and IC. So remember, this has a base of 10 here if you don't see a number. So that's me saying 10 to the minus 3 is IW over IC. So 10 to the minus 3, well, that is going to be 0.001, which is IC. Or that's like me saying 1 over 1,000. So that means the intensity, so therefore, the intensity of a whisper is 1/1000th that of a conversation. So much smaller, okay? It's actually good that this is a problem, because you can see that it doesn't always need to be a bigger number. You're not always comparing the larger number to the smaller number. Sometimes you can have a fraction, right? The intensity could be a smaller number. All right, B. The sound level in normal city traffic is approximately 85 decibels. The sound level while riding a snowmobile is 32 times as intense. What is the sound level while riding a snowmobile in decibels? So let's set up our problem. Our problem is B2. B1 is 10 log I2 over I1. Well, it's giving us a snowmobile is 32 times as intense. So I'm going to say, hey, my snowmobile is the I2, because it's saying that I2 or I snowmobile is that's traffic, let's call it IT, is 32 times as strong. So my sound level of my snowmobile subtracted by the sound level of my traffic is 10 log 32. So the snowmobile, and it gave us what the sound was of traffic right here, so 85. That is the sound level of traffic. So let's BS BS minus 85 is 10 log 32. And just calculate what the sound level of the snowmobile is. So 10 log 32 plus 85. And that is going to give you an answer of 100.05 decibels. So a recap of everything that we did is we learned 3 different applications. We had the decibel scale, the Richter scale, and the pH scale. You're not expected to memorize any formulas. All right, just know like where, if I ask you like a pH scale question, just make sure you're familiar with understanding this scale right here. all right? And but that will be applied to you, but just understand what it means if I say, is something acidic or alkaline, okay? Just as understand, where did I get sound levels from in this problem here. Okay, I will see you in class. Bye for now.